Hello everyone, I'm Peggy. I'm going to explain about how to create a model for an amortization table that works for loans. So from the question, the required inputs for the model are the amount of funds to be borrowed, the amount of the final balloon payment on the loan, which should be optional, which means the table should work even if final balloon payment is not used, and the term of loan in years, the annual interest rate on the loan, and also the payment frequency. The question asks us to include annual, quarterly, or monthly payments. So going to the Excel sheet, firstly we need to create a table like this for us to insert the inputs manually. So we create this table and then fill in the requirements accordingly. And for payment frequency, 1 stands for annually, 4 stands for quarterly, and 12 stands for monthly. So after doing this, the inputs is basically done. So let's look at the required outputs. So from the first category, the question asks us to make a table that shows the payment number, the payment amount, which will all be equal if a balloon payment is not used, the portion of the payment that goes to pay interest, the portion of the payment that goes to principal, and the loan balance, and also the total amount of money paid on the loan to date. So we need to, before doing this table, we need to calculate the number of payments, which is the payment frequency times with the term of loans. You can see from the formula here. So this will give us the number of the payment number, which how many period of time. So we create this table which has the number of periods, the payment amount, the interest paid, principal paid, loan balance, and also the total amount of money paid on loan. So for the number of period, the question says that any rows that come after the last payment on the loan should be blank. That means if there's only 10 number of payments, that means the number here should be only until 10, and then the rest should be blank. And then this should be automated. That means if we change the number of payments, for example I put 15 years, the number should change automatically. So to do this, we need to use the logical testing, which is if the previous cell is greater or equal to the number of payments, then this cell itself should be empty. If it's not, then this cell should be the previous cell plus 1. So after we have this, we drag it all the way to the end, so we can get this automated column. So as you can see, like this empty cell, so the number of payments is 15. So if this is equal or greater to 15, this cell should be blank, like this. So this column is already automated. Moving on to the payment amount. So the payment could be calculated using the Excel function PMT. So similarly, because if final balloon payment is used, then the last payment will not be equal to the level payment amount. So to do this, we need to insert this formula, this function, which is also the logical testing. So if this period, like this payment number is equal to the number of payments, which means if this is the last period, the last payment. Then we need to have the payment amount plus with this, which is the amount of final balloon payment. So if it's the last payment, then it should add the final balloon payment. If it's not, which means if it's the middle normal payment, then we should just include the payment amount. So the payment could be calculated using the Excel function. We just type PMT and then we insert the rate, which is the annual interest rate divided by the payment frequency to get the rate per period, and then the NPER, which is the number of payments, the PV, which is the initial amount of funds to be borrowed, and the FV. FV should be the final balloon payment. So if balloon payment is not used, the FV will be 0. So after we insert this function, we just drag down like the previous column. Then this will also be automated. So if we have this 200,000 amount of funds to be borrowed, the payment amount will be 22657.45. This will always be equal. This column will always be equal when the final balloon payment is not used. So for example, if I so this column is also automated. So if I put a final balloon payment of 500, then the payment amount will change because the last payment will be 500 greater than the level payments. So moving on to the interest paid. The interest can be calculated with the formula, which is the interest per period times with the loan balance of the previous period. So after we type in this function, we just drag down accordingly so we can get the interest paid automated as well. So the formula for principal paid is just the payment amount minus the interest paid. Then we can get the principal paid, which is used to pay back the loan. And the loan balance will be the previous year loan balance minus the principal paid, so we can get the current period loan balance. And then the total amount of money paid on loan as required by the question means the accumulated principal paid. To calculate this, we can just use the initial amount of loan minus the loan balance of the current year, and then we can get the accumulated principal paid. So after we have all the functions, remember to drag it down the whole column so the whole table is optimized. Moving on to the next category, not in the table but somewhere near the inputs. The question asks us to include the total dollar amount of interest that will be paid on the loan over its life, and also the effective annual interest rate on the loan. So not in the table but somewhere near the inputs, I put it here. So the total amount of interest is just the sum of interest paid. So we can just use the Excel function equal sum and then highlight the whole column of interest paid. Then we can get the total amount of interest for the whole period of loan. And then the effective annual interest rate can be calculated using this formula. The IM is indicated by the annual interest rate, and then the M is the payment frequency. So to find effective annual interest rate, which is I, we can insert this formula inside the Excel function, which is 1 plus IM divided by M power of M and minus 1, and then we can get the effective annual interest rate. The question also asks us to draw two graphs, which is one that shows the portion of each payment that goes to interest and principal over the life of the loan, which means the interest paid and also the principal paid. And the second one is a graph that shows the balance owed on the loan after each payment over the life of the loan, which means the loan balance. Okay, so to create this table, we need to highlight this and then highlight interest paid and principal paid while holding control. So after doing this, we can insert a chart. So you can see I get this graph. The orange line indicates the principal paid that increases over time, and the blue is the interest paid which decreases over time. So we can get this graph. So to get balance owed on the loan after each payment over the life of the loan, which is the loan balance, we just highlight this number of periods, which indicates the life of loan, and then also highlight this loan balance while holding control. Of course, we need to highlight it to the end, and then we insert chart so we can get this graph. So that's all for my explanation for creating an amortization table model. Thanks for watching this video.